In this video, we are going to learn how to name and write formulas for molecular compounds. Now, from the name, you can guess that molecular compounds are made up of molecules, and molecules usually consist of two or more atoms connected to each other via chemical bonding and behave as a single particle. Now, remember that some elements exist as molecules, such as hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, phosphorus, and sulfur. And I have put pictures of everything down here for you so you can remember them. Now, many compounds exist as molecules, in particular, compounds in which nonmetal atoms are connected to each other, and these are our molecular compounds. Now, these molecular compounds are connected to each other via electron sharing in a fashion called covalent bonding, which is a type of chemical bonding. Again, we will be talking about that along with ionic bonding later in the semester. And sometimes we have a given set of elements that is able to form different kinds of molecules. Like, for example, hydrogen and oxygen in this example can form water, H2O, or H2O2, which is hydrogen peroxide. And same thing for nitrogen and oxygen. It can either be NO2 or NO3. Now, in this video, we will use molecular formulas. So molecular formulas are types of chemical formulas, okay? They give a specific number or specific composition of each atom in the molecule. And so that means that, for example, in the example here for water, H2O, we have two hydrogens and one oxygens. For H2O2, I have two hydrogens and two oxygens. Now let's go through naming of molecular compounds. I wanted to mention that molecular compounds, when naming them, there's so many different categories. And in this video, we're going to specifically talk about inorganic binary covalent compounds. So binary from the name here means we have two elements in the making up our molecule. And there are other molecular compounds such as organic acids and also acid naming that we're going to go through. And in binary covalent compounds, there is two elements, okay, specifically nonmetal elements from groups 14 to 17 bonded to each other. So the rules are as follow. So the first element in the compound is named using the full element name. Then the second element is named using the suffix IDE. And I will show you on examples on the next slide. Now, another thing we're going to utilize is this table right here, which is the prefixes. And by the way, you are also required to memorize these prefixes because we are going to use these prefixes in the naming of the molecular compounds. Now, the only time we will not use the prefix is when there is only one atom of the first element. So in this case, the prefix mono or one is going to be ignored. An example here is CO, which is carbon monoxide, not monocarbon monoxide. Now, what if I have two elements that lie in the same period, how can I name this, or which one takes priority? Like, for example, PCl3. Let's look, where is PCl3 in our periodic table? So it is here in the third period. So phosphorus and chlorine are together here. So in this case, we write the name of the element in the smallest group first. Okay, so phosphorus here is in a smallest group, or acquires a smaller group number, so it comes first. And usually, or most of the time, we write the names of molecular, or we name molecular compounds as written in the formula. Okay, so let's name this together. So this becomes, since we only have one phosphorus atom, so it becomes phosphorus. And then for chlorine, we'll say chlor and then IDE. Now, what if two elements lie in the same group? Now, let's look at this. So, for example, we have here sulfur and oxygen in SO2. So, in this case, the rule for this is we will write the element with the greatest period number first. So, in this case, it becomes sulfur, okay, because sulfur is in group 3, oxygen is in group 2, so sulfur dioxide. Now, the last thing with naming molecular compounds, when hydrogen is combined with either oxygen, sulfur, or halogens, hydrogen is always going to be named first, and then the other nonmetal in the molecule is going to be named, and then we're going to add the suffix IDE. Now, there is an exception for this, so that the names given here for molecular compounds, so for example, HF becomes hydrogen fluoride, okay? And this only applies if they are in the pure gaseous state. And I will compare and contrast that when we are talking about acids later, or in a different video. Now let's check our understanding and write together the names for these molecular compounds. Now let's start with the first one. So we have here 2 iodine, so it becomes diiodine. Okay, and it's okay. This will be considered correct if you have the I's written together. And then for chlorine, we have 6 chlorines. So 6 has a prefix of hexa and then chloride. Okay, now let's do the second one together. So we have 4 sulfurs, so it becomes tetrasulfur. And then we have 4 nitrogens, tetranitride. Okay, now how about we write down the formula for the last one? It's tricarbon, so we have 3, tri is 3, so C3, and then disulfide means I have 2, so this is 2 sulfurs, so S2. Now I want you again to, as we always do, pause your videos and try to work on these set of practice problems. And while you're working on them, I'll work on them too. So for number 1, we have 2 nitrogens, so dinitrogen pentaoxide. Now, it can be written as pentaoxide with the A and the O, or alternatively, it can be also pentoxide. Okay, so both are going to be considered correct. Now, the second practice problem here is we have two borons, so diboron, and then we have four bromines, so tetrabromide. And the last example is silicon, so only one silicon, okay, and then tetraiodide, so we have I4.